In this lecture, I'm going to talk a bit about the basics of electromagnetic induction. Let's think about ways that our knowledge about electric charge and magnetic fields interact. Hopefully you'll remember that if you have a current moving through a wire, a magnetic field will be generated. By the right-hand rule, this magnetic field will encircle the wire. That's all well and good, but what is this electromagnetic induction business? The term electromagnetic just refers to something that's involving our understanding of electricity and our understanding of magnetism. That's pretty simple. Induction is also pretty simple. This is just the idea of something being induced or caused. In this case, we're going to talk about a current being induced. Let's say you have a simple bar magnet and you put a wire loop around it like this. Nothing too exciting is going to happen. But let's say you get a little bit crazy and start waving this magnet up and down. All of a sudden you'll see that a current is induced, either clockwise or counterclockwise, in this wire. This is very strange. This is called electromagnetic induction. So what exactly happened? It turns out that there's a law called Faradays Law of electromagnetic induction that states that changes in magnetic flux are what cause this induced current. So what exactly is magnetic flux? Well, flux, it is a description in terms of fields of the number of field lines passing through some kind of a surface. So if we have a magnetic field that looks like this, the flux will be proportional to the number of field lines passing through this plate here. This means that the flux is specific to this plate. The flux is also dependent on the angle that these lines form with the plate. So when you move a bar magnet, you change where the magnetic field lines are. This means that you're changing the orientation and the number of the magnetic field lines passing through an imaginary plate, such as this one. This represents the flux. So when you're moving a bar magnet, you're changing the flux through this area. If instead you had a wire loop here, you would see an induced current in this loop because of Faraday's law of electromagnetic induction.